Alright, we're back, guys. Today we're going to be asking ourselves the questions: why do some metals last so long while others corrode and rust away so easily? So the answer is electrokinetics and exchange current density. What is electrokinetics? Electrode is the surface where ions and atoms meet up, and kinetics is the rate of reaction. In this channel, the reaction is corrosion, so how fast does corrosion take to happen? Another good thing to keep in mind is what is electrolyte? Electrolyte is what transports the ions, such as water. Water is an electrolyte, transfers the ions. So now that the intro is out of the way, let's talk about exchange current density. So exchange current density is the natural resting activity of a metal surface in an electrode. So natural resting activity of a metal surface in an electrode. So when metal is in water, um, that's like how fast the ions and atoms kind of interact with each other. Because the faster the reaction is, the faster it'll take the metal to corrode. The slower it is, it'll take slower to corrode. So what is the resting activity though, right? Because I said natural resting activity of a metal surface in an electrode. Resting activity is when they're both constantly participating in two opposite reactions at the same time, right? So the forward reaction is basically when atoms leave the surface and enter the water, releasing electrons. The reverse reaction is when metal ions take some electrons and crash back into the surface. So those are the two reactions: forward, reverse. And at resting, they're both reacting at the same time, right? They're going at the exact same time. The metal's not getting thicker or thinner. They're happening at the same time. So that was pretty much it. Like, today's video is pretty quick, but I can also tell you um, how we could stop this um, exchange current density, right? Because if it's high, that means corrosion will happen more. So we want a low exchange current density. So what can we do to get a lower exchange current density? We can make our metal smoother, right? Because if it's smoother, it has less stuff to react with, and that's something better. So if you're trying to like protect a bridge or like a ship or something, make sure the metal is smooth. And something that isn't good but it's bad is carbon dioxide. If carbon dioxide is really if carbon dioxide is like in contact with water, uh, it forms carbonic acid, which can protonate a hydrogen atom, and you know how weak acids are really bad for um for metals because it protonates that hydrogen, and that hydrogen is really small, and it's really small. You know how hydrogen is like on the really top left of the periodic table? It's like the smallest atom. It can really get into the metal's crystal lattice, and it can act as like an interstitial atom, and affect all the intrinsic activities and stuff like that. And an interstitial atom is when, like, imagine like a pattern where it's like 4 4 4. It's in between the atoms, uh kind of manipulating the crystal lattice structure, which makes the metal weaker, makes it more ductile, and then the metal can fail quicker, have more cracks, stuff like that. So thank you for watching my video today. See you in the next one.